Arc Junkies presents Weld Wednesday with AWS, brought to you by the American Welding Society. And now your host, Jason Becker.
All right, ladies and gentlemen, on the line with me today is Daryl Peterson, who is the chairman of the West Coast section of Central Florida. Is it right, Daryl?
That's correct.
So how are you doing this afternoon?
Oh, fantastic. How are you?
I'm doing pretty good. So today we're going to talk about the changes between the 2015 edition and the 2020 edition of the D1.1 codebook. So just go ahead and tell everybody a little bit about yourself, your background in the industry, and some of your credentials.
Okay, so I'm a senior CWI, ASNT level 3 in mag particle and liquid penetrant. I'm API 653 tank inspector, as well as an SSPC, and I don't know that it's even called that anymore, but a level 2 coatings inspector. Been doing this since 1987. First got certified as a CAWI because I didn't score high enough in 94, and then took it again in 96 after I taught a CWI class, which if you want to learn something, teach it. So but that's basically, that's it. I've been in aerospace, petrochem, pulp and paper, automotive, power plants, and currently I've written 2 ASME quality programs from scratch, and I'm currently maintaining one that we've had for better part of 20 years, so at Central Maintenance. So
oh, nice.
That's pretty much my background.
Okay. Yeah, I know I was talking to a mutual friend of ours, Andy Provost. I was talking about setting up like a AS&T section in Central Florida, so that's something we might be considering.
Oh, yeah, for sure.
So let's go ahead and get into it. We're going to discuss the major changes between 2015 edition and the 2020 codebook, D1.1 more specifically, because I guess March they're going to be rolling out the actual test. So if you're going to become a certified welding inspector, this will be the codebook that you're actually testing to. So I would imagine there's some new questions in there regarding the 2020 edition because there's been some significant changes. They've added 2 different clauses, made it a little bit more robust, and then there's some new information in the qualification section. So let's go ahead and dive into it. I was at a presentation of yours about a month ago where you talked about the updates and changes, and I thought, well, hey, man, this is good information for me, so it'd probably be good information for all the listeners to have access as well. So go ahead and take it away, Daryl.
Yeah, great. So I think COVID time has affected you a little bit. It's probably a little bit longer than a month or 2.
Was it?
I think it was October.
Okay. So,
yeah, it's been a while, but
seems like yesterday.
Yeah, I know. COVID time just is really crazy. But so, yeah, I think the major thing right off the bat that anybody that looks at the 2020 code is going to see is that they changed from the 2-column format, and it's now just a regular, like reading a book. It's 1 column, and that's pretty nice because, if you get down to the bottom of the page, you don't have to go back to the top of the page. So that's pretty nice. They did go from 9 clauses. So in 2015, the 2010 edition went from 8 to 9. They pulled everything from the tubular and put it in its own section, and it's almost like its own little code because it's got the design and everything. Inspection is all in that clause. So in 2010, 15, they moved it all to its own clause. That clause remains in 2020, but it's been moved in its location, if you will. So the changes that they made, they say were to improve clarity. And AWS has come up, they've got their own little technical service division. So they've written a specification on how to write standards. So they're trying to get all the standards in line with each other. So that's kind of what you'll be seeing as these documents start rolling out. We got a couple more reference tables We've got some the formatting, the order that the things happen in this code changed so that it's the normal progression of how you would do your work. So, and then just some other things they say to improve the ease of use. Basically, there's only 30 pages added from the 2015 code. So let's start off. The general requirements that remains the same, and that's still number 1. That's clause 1. And then the code added 2 clauses, and they didn't change too much. I mean, most of the information was already in 2015, but they gave normative references its own clause, and that's going to be they're referencing anywhere else that they talk about in the code. So if they reference ASME, they put, hey, here's the other bodies that we reference. So ASME, ASNT. There's even one reference for SSPC, and again, that thing's changed. So it's the I want to say Association of, I don't even remember it right now. It's Mechanical Property, AMPP, because they merged with NACE. So it's a coatings inspection thing. It shows up one place and it actually shows up in the repair section. So I don't know that anybody will need to know that, but that's just one thing that shows up there. So normative references, they just list them. They took them from other places, and now they have a home, and that's in clause 2. And the same thing happened with terms and definitions. They have a home now, and that's going to be in clause 3. And just to be clear, that AWS A30, which is the terms and definitions for AWS, is the main set of definitions. If you see a definition in clause 3, it's either been modified or clarified for how the code uses it. And, we had a meeting just Thursday night, and we were talking about the definition of a certified welder certification. In A30, the key word is verification. Mm-hmm. And in the D1.1 code, it changed the word verification to certification. So that's just an example of how they modified a word from the standard A3.0. So they've added those 2 clauses, and that pushed everything else down. So in 2015, design was clause 2, and now it's clause 4.
So everything's just shifted to the right a little bit, just 2 clauses.
Right. So now, I got to do, in my head, I'm doing math because I memorized the 2015. That's when I teach the CWI class. It's like, okay, I've memorized it, and I say, make sure you understand and memorize each one. And now I got to do +2, carry the 1, blah, blah. You got
to rememorize where everything's laid out at now.
Yeah. So I'm still not 100%. I still got to do that math in my head. So then we go to pre-qualification of WPSs, which was 3 and now it's 5. In that section, they've added a couple more base metals into the pre-qualified base metal section. Not a whole lot going on in there. 4, which was qualification. So if you actually have to perform a PQR, that section went from 4 is now 6. Fabrication went from 5 and now it's 7. Inspection went from 6 to 8. Stud welding went from 7 to 9. And then we have another trip up. We actually moved the repair, which used to be 8, to 11. So that moved down to 11, and tubular structures moved to 10. And they did that because, like I said, tubular structures is kind of like its own little subcode. It's got design and inspection, everything else contained in it. But that's talking about new production. So new manufacturing, you're making something for the first time in tubular structures. They ended up moving the repair to the very end because that logically you wouldn't repair something you're making right now.
Mm-hmm.
So that's why they moved it all the way to the end. Let's see. In clause 5, pre-qualification, they changed the format to, they've got subparts, which they didn't have. So back in 2015, if you went to the qualification section, you got subpart A, which was kind of general, subpart B, which was qualification of WPSs, and then part C, which was qualification of welders. They did that same format in clause 5, which used to be clause 3, but now it's clause 5. Now they got part A, which is WPS development. Part B covers base metals. Part C is welded joints. Part D is welding processes that are pre-qualified. Part E is your filler metal and shielding gases. Part F is preheat and interpass temperature requirements. Part G is going to be your WPS requirements. And finally, post-weld heat treatment is part H. So they've broken that out. It's a little easier to find now if you understand those, and it's right up in the front. There's kind of a cheat sheet right there, so it'll help get you to where you need to be if you're taking the test.
I'm glad that they kind of stuck with that format, because I learned in the 2010 edition of the code book first, tested to the 2015 edition when I finally got around to taking the exam. And I noticed a lot of questions seem to come out of that area, and the biggest trip up is finding out, are we qualifying is it a performance qualification? Is it a procedure qualification? And that area kind of lines everything out to the differences between performance and, process qualification of a welder or a welding process. So I'm really glad that they stuck with that format, because it's easy to follow. And if you kind of know in the question that you're working with, or, when you're working with somebody out in the shop or in the field, you know exactly which portion to refer to in the pre-qualifications.
Absolutely. And if you have your own copy of the D1.1 code and you're able to highlight in it, I highly recommend that you choose a color for personnel qualification and a total separate color for procedure qualification, because the tables look similar, if not identical, and you think you're on the procedure qualification table and you're not. You're in the personnel qualification table and you missed the question.
Mm-hmm.
So I highly recommend, if you're going to highlight your code or whatever, that you color code it so that you can see the difference and make sure you know where you're at. And that goes with your Part B spec too. Now you can't bring your own Part B spec in there, but when you study it, you need to make sure you're on this is going to mess most people up, is that if you're talking personal qualification, make sure you're in the personal qualification section.
Mm-hmm.
So the normative references, let me jump back here real quick. They actually reference AWS, ANSI, so other AWS specs, ANSI, which is mostly for your materials. They do reference API, ASME, ASNT, ASTM, Canadian Standard Association. I think that one's coming out of the Section 8, where they talk about who's qualified, what is the definition, or who's qualified to be an inspector. And they actually did a real good job of changing that one up, because before they used to say it was the Canadian Welding Bureau, and just kind of left it at that. And that's not true. There's an actual specification that you have to be a level 2 or level 3 to qualify to be an inspector. And like I said, the SSPC, now SSPC and NACE have merged. So they're now AMPP, which is the Association for Materials and Protection Performance. That's a coding thing. It really, I don't think it'll bother there shouldn't be any questions on this, but if there is, that is referenced because in Section 8, I'm sorry, now it's Section 11, there is a a requirement for 2 inches of clean metal on either side of the weld that you're going to make. And there's some stuff about if you had fading surfaces, you pull them apart, you need to be able to get rid of any rust, and you need to do it to SSPC SP2, which is manual cleaning. And as I told you the other night, that's basically a dull putty knife.
Mm-hmm.
Anything that can withstand that, vigorous. So that's where that came from. It's just saying, hey, we reference this SSPC spec. So. Okay. In clause 3, there's actually 5 new terms, which one of them I don't even consider a term, but they actually called out WPS, Welding Procedure Specification. But
you should know that.
It is. I know. I mean,
I feel like you should not have to look that one up.
You should not have to look that one up. However, interesting enough, and we'll talk about these additions in just a minute, but we have 2 new terms that are concerned with pulse welding. Now, we say waveform, we mean pulse. So if you're a welder and you know it as pulse and you read waveform control, that is what we're talking about. So, and these 2 come from the fact that when you have pulse, you get a high initial current to punch down and get some deep penetration. And then we can through digital means, turn that power down and for some length of time and just fill. So you got a digging and a filling, That doesn't lend itself easy to being able to quantify how much power you're actually using, because you may have a 20% dig and an 80% fill, and your dig may be at a certain amperage, your fill is going to be at a much lower amperage. Where do you find that middle ground? So how much heat, at the end of the day, how much heat are you actually putting into your joint? Mm-hmm. So there's 2 new calculations for doing heat input. So those of us pre-2020 all know amps times time divided by inches per minute. We all know that, or we should know that calculation for heat input. Now we've got 2 others. One is your average instantaneous power, and then one is total instantaneous power. And your machine will tell you that. So depending on what make machine you have, you can get those readings.
Yeah, I know a lot of the machines nowadays, they've got an Ethernet port. Like I know the Lincoln Electric machines with their PowerWave software, they all have our Power Wave Manager, so you can actually plug into the back of the machine and you can see the actual outputs on several different, what's the word I'm looking for? Several different inputs that, it'll tell you your actual outputs. So volts, amps, everything all laid out there in the Power Wave Manager software. I'm sure Miller's got something similar.
Yeah, they do.
I would imagine Fronius has the same thing. Other than that, I mean, you're pretty much stuck using a meter at that point.
Yeah, and the code goes into some discussions about the meters having to be accurate enough to be able to detect these things.
To detect all that.
I guess the biggest thing is, and I could see the committees who are writing these questions, perhaps pitching a curveball, and you think they're giving you the average, and they might be giving you the total, or vice versa. So you might want to look at those if you're going to take the test and understand. There's just 2 brand new equations. Just kind of get a feel for what do they mean when they're talking about average, which is the average product of the amperage, all right, during a welding interval. So it's taking the high peak and the low and averaging it, whereas the total instantaneous is in some of the products and amperages, voltages, and times determined at a sampling frequency sufficient to quantify the waveform change. So that's at sampling at a frequency. And when I talk about the gauges have to be finite enough to actually sample at those frequencies, and they're pretty high frequencies. So one of them is kind of the average. One of them is, hey, we take at specific frequencies. That's really getting deep into the water, but like I said, those two I can almost guarantee. I would bet money they would be in some form or another on the new tests. And then we also have another two gems, which computed radiography (CR) and direct radiography (DR). And these two really reflect. They're very late in coming. They probably should have been in the code 20 years ago, certainly 10 years ago. But computer radiography is just a different way to capture the image. So traditionally, we would use a standard film with a silver bromide emulsion. When radiation hits that silver bromide. The more radiation that hits the bromide, the darker that bromide will become when you develop it. The less it hits it, it doesn't turn as dark. And when you develop out a film, you can see dense areas versus not dense areas. That's how we get radiographs. So now we're going to be using screens. And different types of screens. So they kind of do the same thing when the screen gets energized with energy, certain phosphorus or other chemicals get excited, and those are computed. They're read by a computer, and they're digital images. And for a long time, there was a lot of resistance to it. Some people took to it. A lot of people didn't, because you can't really hold it in your hand. It's just, we talked about it the other night, paradigms. People don't like the change, but it's gaining a lot of ground, has been gaining for a long time. And it's easy to store that. I mean, you can store them forever. They don't degrade like regular radiographs. But for the purposes of the test, now you've got these two different methods of computerized radiography, and honestly, the average CWI wouldn't need to know a whole lot about that. If you take the endorsement for radiography, you'll probably get a lot more into that. But for the most part, as a CWI, you're going to probably rely a lot on your NDT guys to tell you what's going on. And if they can sell it to you, you buy it and you sign off on it, you're good to go. So for the most part, those are the new definitions, and those will be in clause 3. So in clause 5, which is pre-qualified, what they did is they've added they had 4 parentheses requirements, and they added a 5th one for shielding gases. And in that 5th one, so before basically, they reference, and here I'll tell you this, they reference a AWS I which is a combination of GMAW and FCAW. It was a spec that kind of covered everything. It covered the metal core and flux core primarily. Now that reference has been withdrawn. That spec is withdrawn right now. It's not a valid spec at this moment. However, the 5.18 GMAW wires, the 5.20 wires, which is a flux core, get into 529 and 528, which are the low alloys, the higher end stuff for this code. Those specs are out there, and basically it says, hey, if you're using a shielding gas, it's got to be in the spec. It's got to match. Basically, it also says that whenever a wire manufacturer like Lincoln Electric, for instance, if they make it, they have to test it. Whatever they test with, you're basically approved to use it. But this year in 2020, they've added this 5, and they go on to say that for flux core gas shielded and GMAW composite metal core electrodes, the test shall be performed by each electrode manufacturer, brand, and trade name to be used, and they got to do it with those gases. And then the very last sentence is something that's interesting to me, because they say for flux core gas shielded, the filler metal shell have been classified by the filler metal manufacturer with an M suffix, which means you can only use mixed gas. So if you have a C suffix, that's for carbon dioxide, and M is for mixed gas. And mixed gas, you can have carbon dioxide or mixed, but C is going to be carbon dioxide only. So it looks in here, from the way I interpret it, that you are not permitted, I guess, to do just with a C, although you can weld with carbon dioxide because it's considered in the mix. So I don't know. I haven't done a lot of intellectual, talking about all this, but it calls out that it has to be with a -M designator.
Okay.
So if you saw one that said -C, that's not allowed.
So at that point, you'd have to write your own. You'd have to qualify your own procedure with that if you were going to use a -C.
Yeah, and so even on that, it's pretty clear that those have to be. It has to be done by the manufacturer as well. So, like I said, it's just I can tell you that -M excludes the -C. So that might be a real fodder for a trick question.
Okay.
So, not to be confused with what we just talked about, which was the FCAW-G for gas shielding. If you in table 5.7, they start talking about GMAW wires, and there's basically it says electrode ER70S-X. So S2, 3, 5, 6, whatever. That you can use it AR CO2, ARO2, or 100% CO2. But there's in the parentheses, it says except ER70S-G. Now the -G in this one means something totally different. G in this case, because they're talking about the GMAW wire, it's to be agreed upon by the purchaser and supplier. There is no specific requirement for chemistry, yield strength, elongation, or impact strength. So this, don't get your -Gs mixed up. This one is 100% separate than the FCAW with gas. In this case, the -G means that you could get something with 30,000 tensile strength, or you can get something with 200,000 tensile strength. And I'm just throwing numbers out there, but it's not specified. So like if you go on ER70S6, it'll tell you that you're going to get 28% elongation or 22% elongation or whatever. It'll give you a range, okay? But in this case, that doesn't exist. So just be real clear that -G in one case means one thing, and in another case it means something else. Okay, let's see here. So you are required to put your flux core gas shielded and GMAW metal core manufacturers and trade names on your WPS. And we're in the pre-qualified section. You do need to write a pre-qualified WPS. It's not like you can just, oh yeah, it's that picture in the book, with those all the little data they have in there for as welded or as detailed, or you actually have to write a WPS. So in here they're telling you have to use the actual manufacturer's trade name and whatever composition of gas you're using and the percentages of those gases. So just be aware of that. That's one thing that you have to do. And again, that might be something if they're on Part B, if they're having you fill out one of those, you got to make sure you put the manufacturer's trade name in there. That's a code requirement. Let's see. Okay, revisions to the requirements for qualification of WPSs using waveform technology, Clause 6.
This is the fun one.
One of the big ones you were looking for.
Yeah.
Okay, so Clause 6.9 covers the WPSs made with non-waveform, which is what we consider just GMAW, okay? GMAW. So non-waveform conventional welding equipment, okay? 6.9.1 states that a WPS with PQRs performed using conventional equipment can remain qualified and be used with waveform controlled or pulsed equipment, provided the WPS is revised to require heat input determination for production using heat input calculations that we talked about just a little bit ago. So it's going to be the total instantaneous energy or the average instantaneous energy. So what they're saying is that the WPS, you don't have to make a new WPS. You can rev it up one. If you're using numbers, you go from 0 to 1 or from 1 to 2. You don't have to change it. Just update it, the revision, and you add the calculation for heat input using one of those two methods. So that's a pretty easy thing. You don't have to reinvent the wheel. You're just doing that calculation and adding it to the WPS. So what does that really mean? Like we know in the past that for decades, CWIs have been doing it. It's amps times volts times time, which we use the number 60. And then we divide that by our travel speed in inches per minute. So that's a pretty standard. That's real easy. You read the amps off the machine, you read the volts off the machine, you times it by 60, you divide it by your travel speed, let's say 15 inches a minute. So if we had 350 amps, say 28 volts, and we times it by times 60, and we divided all that by 15, we'd get 39,000 joules per inch. Okay, real simple calculation. So when we start digitizing or customizing waveform, we get some pretty great results. We get a lot of lower spatter generation. We can get less overall heat input. We can go out of position. Traditionally, we'd have to go to short arc and to take a GMAW wire, vertical or overhead. Now, because we can adjust the heat input, we can get the digging, do the fill, and still be able to go out of position. But like I said earlier, we could have a very short high amp and then a long lower amp in a one cycle, where normally we'd have like a sine wave. Now it's going to be squared, and we can actually change the height of the amperage. We can change the width of the amperage. So there's a lot of things we can do in pulse and get some really desirable results. So with the new waveform controlled equipment, they generally come with digital meters that can display either total instantaneous energy or average instantaneous power, or both. Some of them can switch. But pulse equipment that does not have these meters may need to be equipped with the appropriate meters that can sample at a sufficient rate. So that's one of the requirements in there. So like with heat input under D1.1 2020, we can use the total instantaneous energy method, where you take that total instantaneous energy measurement, and we just divide it by the length of the weld. So if you've got 12 inches of weld, you take whatever that energy value is, divide it by 12, boom, you're done. That's pretty simple. Okay. If we do the average instantaneous power, we're going to take that times the time that you welded and then divide that by the length. So, and that'll give you the same thing. It's not complicated math. You just need to have the meters to give you those numbers. So it's actually a little easier than doing the old way, but it's new. So a lot of people are, a lot of people don't like change.
Mm-hmm.
Okay. There's some revisions made to the qualification section requirements in section 8. qualification of inspection personnel. The basis for qualification of welding inspectors responsible for acceptance and rejection of materials and workmanship on the basis of visual inspection. That wasn't in the code before. So before, inspectors were accepting and rejecting materials, didn't necessarily need to be by visual inspection. That's clause 8.1.4.2. So they added that actual verbiage. So a visual inspector. Okay. And then the requirements are going to apply to what the code terms as the contractor's inspector. I like to say quality control. So quality control usually means it's somebody that's tasked with doing the activities of inspection. So you're going out, you're inspecting to table 8.1, the visual acceptance criteria. You're the one doing that work. Okay. And typically the contractor's inspector acts on behalf of or for the contractor with all matters relating to the scope. The verification inspector or the owner's inspector, I tend to call that quality assurance, and it's how I teach it in my classes. And they're the verification inspector. So they kind of audit, and they'll go behind the QC or contractor's inspector and make sure that they're doing what they're supposed to. So they might come down and ask for the welder certification to make sure that all the welder certifications are in order. They'll ask for the welding procedure specifications to make sure that those are in order. They might go out and audit a welder that's actually welding on the line, take the WPS out there or write down the amps and the volts and any pertinent information, ask the guy his name, come back and say, hey, is the welder certified for that process? Is the continuity up to date? Was the amps and the volts or anything else, any of the other variables, do they match the WPS? So that's the verification side of it. So they're looking and they're auditing to make sure that QC is doing what they're supposed to do. So what does it take to be a visual inspector under the D1.1 code? And this is assuming that the contract, neither the contract nor the engineer have modified these. So if it's straight up, hey, we're going to go by the D1.1 code, what does it take to be a welding inspector? So there were I think 3 in the past. Now there's 5 different avenues to be a visual inspector. So in the past, it said you could be either a current or a previously certified AWS certified welding inspector to AWS QC1. So I guess I could have made the argument, since I'm a senior CWI, that I'm not qualified because it said CWI, right? So they added the words or senior certified welding inspector. So not that it's a technicality, but I don't think anybody would ever stop a senior CWI from doing it.
Probably not.
Work, right?
And in most, I would say probably, if not all cases, a senior CWI at one point would have been an AWS CWI.
The previous, right?
So you'd fall into the previous category regardless.
So yeah, so they just added or senior certified welding inspector, and that just, like I said, it makes it more better. How's that?
There we go. So
current or previous. Now, in the past, let me make sure that we're clear. In the 2015 and before, the requirement was that you had to be a Canadian Welding Bureau inspector. And that is not totally accurate. That is not totally accurate at all, because it's a standard. And well, before I start messing up, let me read it what it says now. So before it said Canadian Welding Bureau inspector. Now it says current or previous certification as a level 2 or a level 3. So level 2 would be equivalent to our CWI. Level 3 would be the equivalent to our senior CWI. Welding inspector in conformance with the requirements of the Canadian Standards Association, CSA. We talked about that in our normative references. CSA standard W182 178.2, which is how they certify welding inspectors. They clarified that. So in the 30 years I've been doing this, it's just always said Canadian Welding Bureau. So kudos to AWS, to the D1 committee for that. So number 3, the third way you can do it, and this is something brand new in this code. Current or previous qualification as a welding inspector, notice there's no word certified, or senior welding inspector, no word certified, in conformance with the requirements of AWS B5.1, which is the specification for the qualification of welding inspector. So what happens is when you become a CWI, and anybody that's going to take this test should know that there's 2 documents you work out of. You work off the spec for the qualification, which is B5.1, as well as QC1, which is the certification document. The certification document. So you qualify and certify. B5.1 is the basis for QC1. However, it is also meant to be a specification that a company can base their internal training program off of, and they can qualify, and I would argue certify in-house. They won't be AWS certified welding inspectors, but they can certify their inspectors in-house. And this is the D1.1 Clause 3 is the basis. This Article 3 is the basis for that. So so you can use B5.1 to do an internal, and why would you want to do that? Well, let's say that that you work in just steel bridges. Okay. Now bridges also, the bridge code also references it here, but you can tailor your questions. You got to do the same amount of questions. You got to do the same percentage of questions, but you can tailor it to your business, right? So it wouldn't necessarily be as comprehensive as a certified welding inspector. However, it would be targeted to your area that you work in, your industry sector. So there would be a benefit there. Okay. Number 4, current or previous certification as an ASNT, SNT, TC1A, level 2 VT. So now if you're a level 2 VT, you are now qualified to be a visual inspector under the code. And I think in the past, any engineer would have let that happen anyways. And then the good old standby, which was, this is number 5, any individual who by training or experience or both in metals fabrication, inspection, and testing is competent to perform the work. You must have documentation of that. So I would say at the very least, like a resume showing their experience and education. So keep that on file for that person. And then there's some alternate qualification inspector qualifications. So the basis of alternate qualification personnel shall be specified in the contract. So the contract may say, hey, you got to be a third baseman on a pro team, and that's it. So if you're a third, if you need that, then you're qualified. So whatever the engineer says or whatever the contract says, that'd be an alternate. Okay, now in Section 8 again, we have the wonderful addition of digital radiography testing. We've been waiting for this for years. So this just gives some outlines on how you archive, how digital RT is supposed to be performed. It's the average CWI wouldn't need to know a lot about it, but you need to be aware that it's in here. There may be a question about it. It is new to this code. So digital radiography, there we go. They also came out with, they changed the way that they calculate the geometric unsharpness. Now, as a radiographer for 10 years, we've always gone by the ASME method, and that's what they're telling you to do in here. So this isn't something that the normal CWI should be exposed to, but then again, the questions that they come up with from the question committee, they look for just weird, out of the way things. So be aware of this, know where it's at, and what they do now is they are using the ASME boiler and pressure vessel calculation. They just state it instead of referencing it. That's all that's really there. They put in a requirement in section 9, which used to be 7, to the stud welding. They added 9.2.1.1 that the manufacturer of headed anchor studs has to put their ID permanently on the anchor. And I don't know the actual reason for this. My guess is that you could have some kind of traceability. But when we start talking about China parts and stuff like that, my guess is that it's has to do with some kind of traceability and the validity that they're real, and that there's possibly tied to the material test reports.
It would make sense because you get, depending on the job, you get your mil spec reports and everything for the steel or the other materials that you're going to use. So having that on file with the anchor studs would make sense.
Yeah. So like I said, that's just a brand new requirement. And if you had taken the test before, you didn't know this, it's on here now. And then also let's see, in the design criteria for 10.2. So we're in 10, we're in tubular connections, part A. So basically they removed the calculations for static strength of welded tubulars, and they referenced the AISC design provision. So they kind of took it out of their hands and they threw it over the fence, and now it's the AISC. This isn't something that a CWI would be doing. It's something an engineer would do. So if you wanted to check them, if you're a CWI and you were that good and you wanted to check and verify that the engineer did what he was supposed to, you can get a hold of an AISC spec and run the calc yourself if you wanted to. But that's not normal what a CWI does. So just be aware that they took the calculation out and they threw it over the fence, and now it is AISC, the way that they calculate it. Just like they did with UG, they said it's the way that ASME calculates it. Let's see. There's some new verbiage in clause 10.2.3 regarding cyclically loaded tubular connections. It's not, just be aware that's new. If you had taken it before and they had a question on tubular connections that are cyclically loaded, just know that there's new clause there. Typically, if you're going to look it up, you'll see this anyways. So I'm not going to go into depth in it. Okay, now the fun stuff. We added Annex H, which addresses phased array. Okay, there's 15 new pages. Half of the new content, half of the new pages are phased array, which is an ultrasonic testing method. So that's going to be in Annex H, normative, and it's phased array or PAUT. So they've got the scope, definitions, personnel requirements, certification, equipment qualification, calibration, how to do scan plots, examination procedures, you have to write those out, evaluation, data analysis, data management, documentation and reporting, system linearity verification, which is calibration, the essential variables to do it, the acceptance criteria, and discontinuity classification. So I know that sounds like a lot. We talk about data analysis and data management. One of the unique things with PAUT is that we can do raster scans, and the whole inspection can be recorded. And you can actually take that and send it to, let's say you're here in Tampa and you do the scan and you record it. You can send it to level 3 in California, and they can look at it and they can see what was your sensitivity, what was your gain, everything about the inspection, and they can look and see, hey, did you have some settings wrong? They can actually add sound to it so they can increase what you would see. They can remove sound out. If you were scanning too hot, they can turn it down and reevaluate it and pass a part or fail a part. So that's pretty exciting. I got a pretty good story about that, but I don't know if I'll address it here. So, maybe I will. I was out in California working on the New Bay Bridge, a $6 billion bridge. And I was managing 2 different inspection companies, the state of California and a hired one. And they had another issue on the bridge, which wasn't in my realm, but they called in an expert to come out there, and it was Dennis McQuaid, and he ended up a few years after that, becoming a president of AWS. But we went out to dinner, and he's a fascinating gentleman. And I said, hey, I've been working on this phased array with Tampa Tank, and USF was out there, and we were working on bridge components. And I had a very small part in it, but I was aware of it. We were working on it, and we were trying to come up with the appropriate calibration block and to be able to correlate what we were seeing in phased array to what we were seeing on film, and trying to make that work. And this was a couple of years before 2015. In fact, when I was out there, I believe it was 2012, maybe 2013. And I was real excited. I was talking to Mr. McQuaid. I said, hey, yeah, we're looking to get phased array into the 2015. And he was like, yeah, we're never going to abandon the A minus B minus C equals D, which that calculation does not work with phased array. So we'll never go to phased array. And not that I'm throwing Dennis under the bus, but yeah. So I was excited. I was hoping to see it in 2015. I'm thrilled to death it's in 2020. So that's really all I have. You got any questions?
No, I got the book probably a month ago because I'm a little slow. And it's pricey, but it's worth the investment. So I'm slowly taking the time to go through and just read the whole thing once again. I know there's a lot of changes in here. With my work, it's a little bit different because, I'm teaching students how to weld. We're doing some guided bend tests in the lab. So we're kind of limited as to a lot of the stuff that's going to talk about here. Although the advanced waveform stuff, I really want to dig deep into that and actually hook up that, the Power Wave Manager from the Lincoln is something I've been wanting to do just to kind of see what type of data that I'll have access to once I fire that up. So I'm interested in, kind of learning that whole aspect of it and then walking the students through it once we get to that point.
I will tell you, go on the AWS.org website and download the latest errata. I think it's 11 November of 2020. And there are a ton of changes, especially when you talk about preheat temps in section 5. There's 11 pages of stuff, and the same thing happened in 2015. I mean, when you significantly change a code, you're going to miss stuff. So, but I will tell you to check that out and make those changes or put them in your code, and that goes for anybody else too, especially if you're going to take the code for the first time. Understand that there's some changes if you take your own code.
Okay. So what are some of the recommendations you provide to somebody that's looking to take the 2020 edition code book, or just some kind of recommendations to areas of study or like methods of test taking or marking out the code book as far as like tabbing or highlighting?
So I'm going to tell you, I never went to the classes for tabbing or highlighting. So the major thing that I tell my students is understand and know that if you're talking about personnel qualifications, stay in your lane with personnel qualifications, because like I said, those tables, the table for personal qualifications for positions, and that looks identical, but it's not. There are different. So if you're working on personnel and you're in the procedure qualification table, you're going to get hosed. And AWS knows that. They know that table contains different, and that will be one of the answers that you have to choose from. And you go, oh yeah, well, I read it. Here it is.
Got it. Here we go. Next question. Yeah.
Yeah. So absolutely know what you're in. Now, back in the day, and it's getting harder and harder and harder, but it used to be eight clauses, and that was easy to remember. You had general, fabrication, pre-qual, qualification, fabrication, stud welding, and repair. Those were just easy to remember. And when you read the question, what are they? You gotta see, what are they actually asking you, and what section would that be in? You gotta kind of do that. And if you're like me, you look in the back of the book in the index and you look for. Let's say they're going to ask you a question about fillet weld size. So fillet weld size, you go, okay, well, maybe that's in inspection or maybe it's in fabrication. Like the two places it could be. And then you look at those first, so if it shows up in section 3 pre-qualified, you're going, I don't think it'd be there. You go to the section that you think it's going to be in and you look at those first.
Mm-hmm. And that's kind of what I did when I went through mine. The first time I just sat through as a section rep. So I got a copy of the code book. I got to tab it all out. But when I actually went to go take the exam, I purchased a whole completely separate code book and just tabbed the clauses. But I memorized the clauses. I knew the information contained in those clauses. Tabbed the clause numbers. So number 1, general requirements. 2, design. 3, pre-qual. Just so it was easier to get to that clause while taking the test. And then at the bottom of the book, I just tagged the first table in each of the clauses. So table 1, boom, I can grab and work through there because the figures are right after the table. So it was a lot less tabs, a lot less stuff to look for. I could put bigger tabs on there to where it was kind of bold and stuck out. Like, okay, I need to get into clause 4 qualifications. It's just a big, robust tab I can see and grab a hold of it. It just made life a lot easier. And then I know with the 2010 edition, all the metric and standard, like when you go through and you look at the pre-qualified joints, there was one section for metric, one section for standard. And I kind of had a good idea that they weren't going to be testing for the metric units of measurement. So I just paper clipped those together. So that whole section, I knew that was kind of out of bounds for the test that I was taking. So that was like another 10 or 12 pages that I didn't have to refer back to while I was taking the exam. But I think in the 2020 edition, I think it's a kind of a mix of metric and standard throughout that area, if I'm not mistaken.
Yeah, I mean, I would tell my students to bring rubber bands or paper clips, and and some test guys won't let you do stuff, but that metric section was off, and I basically, once you got to the back of the last clause, you can rubber band that together because there's out to the index, because that's commentary or normative reference stuff, and there's not too many questions that even come close to that. So
right.
I do tell, like I said, my students, I tell them to write 2 or 3 welder qualifications and follow the rules, and the same with the welding procedures. I tell them to go to Lincoln or Hobart, ESOB, download a 7018 data sheet or ER70S3 data sheet, and just kind of write what they think would be an appropriate WPS. Once you do that a couple of times, you kind of get a feel for, oh, here are the rules. It makes Part B and some of the questions on your code test much easier.
Right, and that's what I get for. So if there's any welding instructors listening, like I've said before on the podcast, Lincoln has a great resource manual with their educational portal, and one of the documents that you can order as many of these books, catalogs, or documents as you want from Lincoln Electric to pass out to your students for absolutely free. I send out it's the C1.10, and it has a list of every electrode that they make, the considerations, the typical applications, amps, volts, wire feed, speed, like all that information, the technical information is in there, the chemical composition of the wire, Sharpie V-notch values, all that information is in there. So, if you're using, Lincoln 7018 Excalibur H4R, you can actually open up the book, pull it up, and there's all the specs, operating parameters, everything that you need to know to kind of fill out that information on your WPS all on one sheet. And they're free. And if you're not an educator, you can actually just go to Google and download that manual. And I know you can do the same thing with ESOB and SelectArc and all the companies that produce these electrodes. All that information is right in there. Typical operating amperages, procedures, and it's all free. You can download it right to your phone.
Yeah, and you mentioned you tickled me for a second when you said 718 H4R. We had our section meeting the other night, and I was telling you after the meeting about the period of effectiveness or the atmospheric exposure limit.
Right.
There, I had learned it back in the day in the 90s that it was 4 hours. But if you've got the AMR designator H4R, those are good for 9 hours. So that's something that students should be aware of, and the temperatures that you keep your rods at.
Mm-hmm.
And when I teach, it's funny. When I teach my students, and I taught about 2 years ago. Again, COVID times got me messed up, but I taught a free CWI class, about 80 hours worth, to instructors, and I invited from 5 different counties to come and take it. So we took it up in Orlando. We did the class at Irwin Technical College in Tampa, and we went up to Orlando, and I had 4 guys, one in each class, 2 in the middle class, I believe, and I popped my head in to just to see the landscape, and guess who was just inside the door?
Hard telling.
Would be Redbeard from Weld.com. Do you remember that? It was about 2 years ago. I popped my head in. I'm like, oh my God.
I'm trying to think of which location it was, but yeah, I used to volunteer as
in Orlando.
What's that?
Was that a hotel right there in Orlando?
Yeah, they've changed it a couple times because I used to volunteer as a proctor for Saturdays to help out the the test supervisor, and I took over for Bill as he was the test supervisor for the longest time. But he's out of Ocala, so he would actually drive down to take the Bill Myers. He's actually a former AWS president. He's with the North Central Florida, but I used to be his assistant until he was kind of tired of making that drive to Orlando once a quarter. So I took over for him, and then I can't remember who the new guy that ran it for quite some time, and I don't know that he's doing it anymore. Damn it. What's his name? Now you got me thinking.
Well, it's funny because I was like, oh my God, and we've met since then because we've done a couple of district meetings together.
Mm-hmm.
And I bounced a couple things off of you and whatnot. But it was funny because after the first session, my first guy came out, he goes, oh my God, that guy from all those videos, because we use your videos, quite a few of your videos in the class, So he's like, that guy that you show on the videos, yeah, he's in there. And then all of them were all like, oh my God, he's like you're internet famous. So
it's still kind of weird to me, like when people recognize me, because it's like YouTube's such a small niche. But then again, so is like the welding community. So it's always cool to run into different people and see how some of the videos that we've done have helped people out, on their welding journey.
Absolutely. And the fact that when we talk about stuff, especially in metallurgy, when I'm doing that, I do a long part in there. I don't remember. I wish I could remember the guy's name, but there's a video AWS put out. The guy's he's got the whole welding cap thing on, and he's quite entertaining. But he does the story about the trailer and the Wyoming weave, and here lately I've pulled your weave versus stringer because in his video he's welding on T1 514 material, and heat input is a big issue. And while he says that, being able to show it with your video where the Sharpies were just terrible, that is where it kind of ties it all together for my students.
Mm-hmm.
So,
and that's what a lot of people don't realize is when you start weaving, your travel speed is decreased by half as compared to a stringer. So you're throwing a lot of heat input into that material as you're traveling up. Yeah, I mean, it looks like you're depositing more weld, but you're just depositing it side to side instead of vertical. So if you have to control your interpass temperature, run your stringer. You can let it cool down for a second and then run your next pass. But with a weave, I mean, you're putting like a lot of kilojoules into that just because your travel speed is so far reduced.
Yeah, and we work with some super duplex stainlesses, and we got. I also work with like 9 chrome and whatnot. So there's a lot of things that we have to do. When you talk about A36, how it's vanilla steel. How crazy you can pretty much dunk it in water and be okay.
Mm-hmm.
But there are grades of material out there that you cannot do that. So, and I think that's I know back in the 90s when I was learning, there's so much, a CWI that's going to take this test, there's so much you need to know. And, I can tell you, being in this business for 35 years, and in the last 10 years, being at a high level, I still learn stuff every day. And I would encourage anybody out there, if you're a member of AWS, start watching the message boards, because I learn stuff off there all the time. And there's some pretty prolific names on there that, if you start watching, you'll know who they are. But you can learn stuff because things are situational as well. While the rule of thumb is always this, and then you have a little twist, and all of a sudden it's 180 degrees from what you thought it was.
Yep.
So those are the little things. And I told you the other night, under ASME, which is a different code, the 1.1 times for short arc. If you're qualifying, whether procedure or person, when you qualify with short arc, you get 1.1 times the thickness. So if it was 1 inch, you get 1.1 inches. But under ASME, and I didn't know it, and that's my playground. I've been playing in it for close to 20 years. I literally did not know that there was a provision that if you test on over ½ inch, that it's 2T like everything else. So a customer came to me and he's like, hey, we need to take a look at this. It should be 1.1. And he's been in this business as long as I have. So, he didn't realize it either. So one of my main inspectors came back and said, no, it's over ½ inch. And he showed me the clause. I'm like, oh, I'll be darned. And then I said, hey, Jeff showed me. I said, I can't believe I didn't catch it. And he's like, yeah, I stand corrected, So you got to go to the code. You got to double check stuff and make sure that for whatever condition you're dealing with, especially if you're taking the test, whatever condition you're dealing with, that you look up that condition.
Right.
Because like I said, it can, normally it could be, like I said, if you go back to, hey, if you got 70-18 rod with no other information, it's 4 hours atmosphere exposure out of the can or out of the rod box. But if they put an M or an R designation on it, now it's 9 hours. So there's a lot of that in there. I tell everybody that's going to take the test, because it's gone on every test I've ever taken. electroslide welding is vertical progression. I has been on every test that I took it in 94. I took it in 96. I took it in 2009. And it's been on every test. So that's what I tell people. Hey, just know that electroslide, you don't even know what electroslide welding is, but it's vertical.
Yeah.
Vertical progression. I know what it is. I've seen it. So
right. No, that's great, man. I appreciate your time coming on the show. Kind of, like I said, when I sat through your lecture, I guess October, with COVID time, I thought it was great talking about the different changes and stuff in 2020. So I figured, what better person to have on the show to talk about the changes and kind of get the information out there for those that are. I get a lot of questions from people via Instagram. Hey, I'm studying for my CWI exam. What are some recommendations you could give me and stuff like that? And then with the current changes and stuff, I just thought it'd be a great idea to have you on the show and kind of get that information out to the masses so they got one more resource to help guide them through their journey to becoming a CWI.
Let me mention one more thing before I let you go, or before you let me go. There's been a lot of chatter on the boards. I believe it has to do with the tubular section and fillet weld qualification. And where it comes to, CJP automatically qualify you for unlimited. PJP automatically qualify you for unlimited fillet welds. I believe that you got to really backdoor it in section 10 in tubular. So if you're studying to take a CWI, you might want to take a look at that and figure that out before you take the test, because it's kind of jumbled up. It still does qualify you for unlimited fillet welds, unlimited thickness, unlimited size, but it's a weird way how you get there. So if I remember correctly, so I know that it's been brought up 2 or 3 times as I just kind of monitor what's going on those boards. I don't have it ready to present to you today, but that's something that you might want to look into, because that would be a great question, because it's so entangled that it'd take up a lot of your time, and that'd be a great question by the question writer.
Okay.
So, but with that, man, I appreciate it. Thank you for having me on.
Oh, thanks for coming out, man. I really appreciate your time. And like I said, spreading the word to everybody that's tuning in.
Yeah, 10-4. Thank you.
All right, ladies and gentlemen, thank you for tuning in to March's episode of Weld Wednesdays with AWS. You can purchase your own copy of the D1.1 2020 edition, as well as find a full list of requirements to become a CWI at AWS.org. I hope you found the episode educational and informative, and that you'll join us next month on the first Wednesday for another episode of Weld Wednesdays with AWS, brought to you by the American Welding Society. Never stop learning, and until next time, make every weld better than your last.